That happened to us a bunch last semester.
So, Brother Wilcox, if you're watching this, I forgot to push record, and so we're done. We're already like an hour and 10 minutes into this, and we finished the group present or the participation stuff, preparation. Now we're doing the quiz. Okay, so question 8, what did you get, Daniela?
68.
68. Sí, 68.
That's no big
Okay,
deal.
suppose that the z-score comes from a standard normal distribution. Use the normal probability. Oh, we can use it to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places. Let's open that puppy up.
What percentage will be between 68.27 or 6827?
6827. So 0.6827.
Yeah.
68%.
Yeah, I think. I mean, it wanted us to do it with this thing.
Yeah, I know the app went. I did it. I put it in.
Okay, you just opened it up. Okay, I thought you were just saying that number from the question 8.
Huh.
But you wouldn't have gotten 27. Okay, suppose the z-scores come from the standard normal distribution. Use the normal probability applet to answer this question. -2 and 2. Plug that sucker in. What'd you get?
It's
I got 0.9545.
9545.
Nice.
.545.
Cuatro? No.
9.5.
95.
95.
4.5.
45.
Okay, and then if you plug in 3 for the z-score, it gives you 99.9973.
0.9973.
Wait a minute. We are in 10, right?
We just did 10, and then we just did 11 also. So what do you have for 10?
The last one was .9545.
Yeah, 9.5, 4.5.
That was 10.
And then we are in 11, right?
Yeah, 11 is 0.9973.
Point. Okay. 9973. Right.
And then for 12, it says, look carefully at your answers to the last 3 questions. What do you observe? Well, they do match the rule 68, 95, 99.7 pretty well. But what do the other ones say? As the z-score increases, the area between -z and z decreases. False.
Ooh.
And then for the other one, the probabilities double as you move from z1 to z2. That's also false.
It's the first one.
Yeah, the first one.
Right?
Yep.
Yep, the values match. Okay. Use this for the next 6 questions. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. Requirement is given in terms of number of grams of good quality protein that must be consumed each day per kilogram of body per kilogram body of weight.
Of weight.
The population mean protein requirements for adults is 65 grams.
0.65 grams
0.65 grams
per kilogram per day.
per kilogram per day. Per kilogram per day.
And the standard deviation is 0.07 grams per kilogram per day.
0.07. Okay. What proportion of the population have a protein requirement that is less than 0.6? Well, let's figure it out. So we're just gonna, I guess we could do points still. 0.60 minus the mean, 0.65, all over the standard deviation, 0.07 equals the z-score. So that is 0.6 minus 0.65 divided by 0.07.
What proportion of the population have a
So I got 0.7142. And then I plugged it into the applet, and I got 0.2376, so 23.76%. And it says give it in as a decimal, so 0.2376. Yeah, 76. You guys want to double check me?
But we only need to write 3 decimals, right?
Is that what it says? Only 3? Oh, so round to 0.238. Okay.
Right.
So now, question 14 says, what proportion of the population have a protein requirement that is more than 0.6? So we can use the rule of probabilities and say that 1 minus our last number, which was the proportion of people who required less, equals this number. I got 0.762.
Yep.
So now we're looking for what percentage of the population requires less than 0.7. So 0.70 minus the mean, 0.65, all over standard deviation, 0.07 equals z-score.
What's this?
0.7 minus 0.65 divided by 0.0.
What's the z-score you got?
It's going to be the same thing. It's just going to be on the other side.
So it's 0.238.
Yeah.
Yeah.
How lame.
It's
Why does that make
0.238.
Yeah, because it's 0.2376.
Well,
Oh,
so hold on. Yeah, that makes sense because 0.7
Yeah.
is only 0.05 above. It's and 0.6
Since from the
is
mean, yeah,
0.05 below. That makes sense.
we didn't even need to do the calculations because we just looked at it.
So find the
Yeah.
ones that fit the protein requirements that are between 0.6 and 0.7.
Don't even need to calculate it. We can already figure that out. So we add up.
Well, don't you do 0.238 times 2? And then
You can do that.
And then 1 minus that?
Right. Or you can do 0.762 minus 0.238. Let's see if that works, if that equals the same thing. So you do 2 times 0.238.
0.524.
Yep. And so if you multiply both answers from 13 and 15, if you multiply that by 2, or added those together, I guess, and then took that from 1, you got the same thing as taking 0.238 from 0.762.
Okay.
Lame.
Okay.
Find the probability that a randomly selected person will have a protein requirement that is between. Hey. What did I? Oh, I just didn't write it down yet. Okay. Find the 35th percentile for the protein requirement for adults. Shoot, do you remember how to do this?
I do not. Let's think about it.
Okay, 35th percentile. Let's think about this. Okay. So the mean is 50. So we need to find the z-score and x.
The one we did before, so we had x minus 1800 over 600 equals the z-score.
Right.
So in this case, it would be x minus 0.65 over 0.07 equals the z-score.
Right. So now we need to figure out what would the z-score be of the third. Oh, I remember how we did it in the we did it on this thing.
Probability.
We did it on the app.
How did we do it?
You select only the left side. So only the left side is blue.
Mm-hmm.
And then you put in 0.35. Is that what we're looking for? The 35th?
Yeah.
Yeah.
Okay.
So then you put in 0.35 and then you push enter and it gives you a z-score of 0.385. Yeah, 0.385.
So
that equals. So we do that times the standard deviation plus 0.65. The mean equals x.
Mm-hmm.
What's x?
0.35 times 0.07 plus 0.65 is 0.67695. But 3 decimals says 0.677.
67. 0.67 what?
7.
All right, same thing, but 80th percentile.
Okay, so now we go back to normal probability applet. Click on the, no, we still click on the left side. But we do 80.
Z-score of 0.824 or 842.
Right. Same deal. So what do you get for this one, Daniela?
We are in 17 or in 16?
What are we on? No, we're on 8. Did you get 17 already?
No, I am doing, but I am confused because 16 is 0.677, right?
That's 17. 17 is 0.677.
Oh.
16 was 0.524.
0.524.
Yeah, that was for 16. What did you get for 15?
I know say I'm so lost. Okay, I was lost in 16, so I'm doing now 17.
Did you got 15 though?
I have 15. I was doing 16. So now
16?
I'm
Okay,
doing,
did you see how we did 16?
now I'm doing 17, right?
Right, but do you understand how we did 16?
Right. I was doing that and then I lost. I don't know what happened.
Oh, sorry. Okay. So
it's fine.
So do you want to? So let's talk about what we did for 17. If you want to look at my screen, I'll just screencast it to you. So look on my screen.
There we go.
Okay, so the question for 17 says find the 35th percentile, right? So we go up to this
Yeah.
probability applet. We make sure this side is the only side that's shaded. And then we go 0.35. And then you see the z-score down here? So that's what we're going to use to plug back into our equation.
Okay.
And then if you see on the top one right here, right there, that's the equation to find x.
You only multiply.
You multiply, but then you add. You multiply the z-score by the standard deviation, and then you add the mean.
Okay.
So what are the numbers you're using?
Using 87 multiplied by 0.3, like minus, like the thing that you use, like minus 385.
So you should have 0.385.
0.385 by multiplying.
So multiplied by 0.07. And then you find that number. So what does that equal? Do it in your calculator and I'll do it. So 385 times 0.07. So what is that for you?
0.0334.
It should be 0.02695.
You add 65, right?
So, and then if you add 0.65, you get 0.676. So can you see my calculator? Hold on, let me make sure. Can you see that?
Yeah.
Okay.
Yeah.
So that's what you're looking at. So you want to do the first one is 3.385 times 0.07.
See?
And then after that you add 0.65.
Okay, yeah.
Okay. So then the answer for 17 is 0.677.
6, Thank you.
Okay, and then for 18, Andrew, did you do 18?
I did not. I got a phone call.
So for 18, it's just, I think it's less than 80 percentile, right?
Yes.
For the protein round.
So the z-score is 0.842 times 0.07 plus
0.65.
So that should be 0.71. Well, 0.709, I guess. 0.709.
That's rounded to 3.
Yeah, because it's 0.70894.
Yeah.
Let me think if this makes sense. Because we might need it to be the 35th percentile is not going to be higher than the mean. So I think 0.67 might be wrong. I think we need to have it be a negative number.
Okay, we got 3 wrong.
Yeah, so 17 needs to be negative. I see why that's wrong.
17,
so it's going to be
17, 15
negative.
I got wrong, and 10 I got wrong.
So 17 should be 0.623. That's what 17 should be, because we didn't do a negative number for the z-score. Okay, what other one did we get wrong, Andrew?
We got 15 wrong.
10.
And 10 wrong.
Okay, let's see 10 first. Okay. 10. Suppose z-squared circumference. Use the normal applet to give the answer. What proportion?
Doi.
For 10?
I didn't look at 10.
Like
I was looking at
11
15.
is right, but 10 not.
So 10 should
11
be
is right, 10 is wrong.
10 should be 0.9545.
Yeah, that's what I put. 3 decimal places.
Oh,
But 11's
So-
not wrong, and I didn't do it to 3.
955. Yeah, because it only reads 3 and you didn't round. So it still read 0.997.
I did 0.9. I had 0.9545. Oh, yeah. I see what you mean. Yeah.
Yeah. Was 9 wrong?
No,
Was
9's right.
1945, right?
So 9 should be 0.683, right?
It doesn't say. Oh, it does say round to 3.
I'm gonna do 0.683.
I did put 6827. I got right.
Okay, I'm gonna keep it 2 then.
Okay.
And then so 10 was fixed. What was the other one? 15?
15. And I
Okay,
think
what
I see the
portion-
problem with 15 because I think we did over 0.7 grams.
You're totally right.
0.238 is the percentage of people who need over that, not the percentage
Yeah,
of
so
people who need.
it's just 1 minus 0.238.
Yeah. So before you save it, let me get into it again and fill it out,
So that's
or before you submit it.
What is the problem with 15?
So 15, we put the number for everything above 0.7
Uh-huh.
and for everything below 0.7.
Oh.
Yeah, so the answer for that is 1 minus the answer we had. So that's
Yeah.
0.762. You can see your answers when after you submit it though, right?
Yeah.
Yeah, so I'll just submit it and then
Okay.
let you know. Okay. Yes, submit.
All right, and then as you scroll down, just scroll with me. 1 and 2 are good. 3 is 1. 4 is false. 5 is true. 6 is C. 7 is B.
Uh-huh.
8 is
78.
78.
8 is 68.
68.
68. Yeah.
9. I'm not reading them.
Right. And so 9 is 0.683. I got it wrong on that. I put 0.682 and it's 683.
Okay.
So I'm gonna redo it.
And 10.
10 I got right this time. 0.955.
Okay.
11 is 0.997.
Okay.
12 is the values match the
Yep,
6895.
for that one.
13 is 0.238.
Okay.
14 is 0.762.
Okay.
15 is also 0.762.
Okay.
16 is 0.524.
Mm-hmm.
17 is 0.623.
Yeah.
And then 18 is 0.709. Let me get back into it now.
Okay.
Is my turn right? To save it?
Yeah, you can save it and submit it.
See?
Okay, so true,
Yeah, we're 100% on that one.
true. So let me know what they are again. For 3 is 1.
3 is 1. 4 is false.
4 is false.
5 is true. 6 is C. 7 is B.
7 is B.
8 is 68.
Uh-huh.
9 is 0.683. 10 is 0.955. 11 is 0.997. 12 is the first one. The value matches 68, 95, 97, or 99.7. 13 is 0.238. 762. 15 is 0.762. 16 is 0.524. 17 is 0.623. And 18 is 0.709.
0.623 and then 0.709.
Mm-hmm.
Okay. Cool beans.
All right, guys.
We'll
Okay.
see you next Tuesday.
Adios. Till
What
next week.
time the next Tuesday?
We could do it earlier if it's better, or now is fine too.
Um, hmm?
For me, it's okay after 7.
Okay, I think we should do it earlier.
Okay.
Yeah, today was just different because I had a meeting.
Okay, let's do 7 then.
All right.
All right.
Okay.
See ya.
Yeah. Well,
Yeah. Thank you.
yeah.
Yep.